Good morning, guys. Today we're going to start talking about forces. So, let's just define a force. What is a force? I know probably in the past you've had teachers define force as a push or a pull. There are better definitions for force. So, we're going to be using the definition that a force is an interaction between two objects that has the ability to change motion. Forces don't always change motion, but a force is required in order for motion to change. And here are some examples of forces. Your muscles can provide forces onto an object in order to change its motion. Wind, like air, moving air, can also move objects like flags flapping in the wind, your hair. And then you also have the one type of force where it's caused by mass. The mass of the Earth causes a gravitational pull on you and me and every other object nearby. All right, those are just some examples. There are a few different types of forces. And let's see. Make me smaller. And there are contact forces. In order for a contact force to exist, the objects have to be touching each other. Whenever two objects touch each other, they both exert a force on each other at the exact same time. We'll be talking more about that when we get to Newton's laws. There are also field forces. These are forces that can act at a distance. So sometimes they're called at a distance forces. I think your textbook refers to them that way. I call them field forces. There's the gravitational force, the electromagnetic force, nuclear strong force, and nuclear weak force. We will be mostly concentrating on the gravitational force in this class. We might talk a little bit about electromagnetic, especially when we get to the structure of atoms. Less so with the nuclear strong and nuclear weak force. All right. Measuring force. So in our everyday language, we would talk about a unit of force called the pound. You guys are probably pretty familiar with pounds. You probably know how many pounds you are, roughly. That is a measure of the gravitational pull on your body, which is a type of force. In science, of course, we use different units. Those units are called the Newton, named after, you might guess, Isaac Newton, since he was one of the first and definitely most well-known people to study forces. 1 Newton is the amount of force needed to accelerate a 1 kilogram object by 1 meter per second per second. And that's a very specific definition. It might not mean a whole lot to you right now, but it is a very specific scientific definition. 1 pound is about 4.5-ish newtons, 4.448 newtons, just to give you a reference point. We will be using these spring scales in class to measure force, and it'll give you the force reading in newtons. It might also have pounds on it, I'm not sure. All right, and also force is a vector because the direction that something is being pushed or pulled is very important for its change of motion. So if you are pushing an object in one direction, and it's probably going to be moving in that direction, depending on what other forces are there. But it all depends on the directions of those forces, what direction they're acting in, and whether one is able to overcome the others. The sign on a force, whether it's positive or negative, tells us which direction the force is acting in. So if you look at the picture of the guy pushing a box, this picture has defined the right as a positive direction. So this particular box is being pushed in the positive direction. So the force is the net force is a positive 10 newtons. And then on the other side, he's pushing in the exact opposite direction with the same amount of force. So that's a negative 10 newtons. So the size of the forces are the same, but they're in opposite directions. we use a scale when we draw vectors to represent force. And the length of the arrow tells us something about the size of the force. So if you look at this picture right here, where you have centimeter ruler and you have a scale, 1 centimeter equals 1 Newton. This line, this vector, is 5 centimeters long, and that tells us that the force is 5 newtons, because each centimeter represents 1 Newton. There are 5 centimeters, so 5 newtons. The scale isn't always going to be 1 centimeter equals 1 Newton. It could be 1 centimeter equals 10 newtons or 100 newtons. It depends on what is needed in the picture. All right, we have the force of friction. Friction is a force that happens when two surfaces are in contact with each other. And if one of those surfaces is trying to move past the other, then there's some sort of friction between them. The specific type of friction depends on the motion that is involved in the whether it could be sliding friction, no motion, that's static friction. When they're sliding past each other, that's sliding friction. If an object is rolling, that's rolling friction. You can have air resistance, or sometimes it's called air friction. And you can have like water or viscous friction. They're actually really similar to each other, air friction and viscous friction, just different types of fluids. And basically, friction arises from the imperfections, teeny tiny microscopic imperfections in a surface. And it can also come from the electrostatic forces that are between the atoms in the two surfaces. So, see that. Okay. So friction is one type of force that we will be dealing with quite a bit this year. Friction is, there are different types of friction, like I said in the last slide. When you are first trying to push something, and it doesn't move right away, that is something called static friction. So if two surfaces are in contact with each other, but they're not moving, that's static friction. Static meaning motionless, no changing. So for example, when the box is being pushed on one side, but it's not moving, there's static friction in between the box and the floor. Once it starts moving, then you have something called sliding friction. And that is also between the box and the floor. It's a different type of friction, which is why we distinguish between the two. And actually, static friction tends to be bigger in size than sliding friction. So you have to overcome static friction before you can get an object moving and deal with the sliding friction. All right, so in the lab that our in-person class will be doing today, and my fully remote students will be doing as from the video, you will have these little, they're like sleds, they're paper sleds, and you're going to put different amounts of mass on the paper sleds and pull them and measure the amount of force that it requires to pull them with a constant speed. You have to move it at a constant speed in order for the pulling force to equal the force of friction in the other direction. I want you guys to take a moment to think about what type of friction you'll be dealing with. Is it static, sliding, rolling, air friction, or viscous friction? And then take a moment to think about that, and then you'll watch the video and do the lab. All right, guys, see you later.